Our last part here is going to be talking about that rate of change um, and looking at its relationship as well as determining the rate of change. So our first problem here is tickets to Valley Fair, at least when I was in high school, were $30 for 2 and $45 for 3. So what I want to look at here is first let's take step 1, and step 1 is going to be do both values increase? Does one value increase and the other decrease, or does one value not change? And when I look here, I look and see that I have here cost, and while it doesn't have a label, these are the number of tickets. So I'm going to put cost and number of tickets, or ticks, since you're using it. Now when I look here, I'm also going to take a look here at my step 2 of determining dependent and independent variables. Well, I see that the number of tickets determines the cost, so therefore that makes the number of tickets our independent variable, because how many we buy is up to us. And that makes this our dependent variable. And remember, dependent is y, independent is x. And also then taking a look at our change in y over our change in x. So when I do that, I see that my change in y is going to be an increase of $15. And our change in x is going to be an increase of 1. And so therefore both values are going to increase. And what that means is that our relationship is going to be positive. And the nice part is this right here is already 15 over 1, which means we can just add our labels. So 15 is our increase by $15 per 1 ticket. Let's take a look at the next example. The late fee for a movie rental from Redbox is $2 on the first day and $2 on the 7th day. So I see here we've got money, and we've got first day and 7th day. So when I look here, that is going to be cost and days. Now the nice part is days is a form of time, which automatically makes it our independent or our x value, and that makes money our dependent or our y value. Now when we look here, I see that the change in y is going to be 0 because the money doesn't change, and the change in x is going to be a change of 6 days. Now I notice that means that here we have one value not changing, therefore that means that this is a 0 relationship, because if I were to graph this, it would come across and be $2 no matter what. So therefore the change is going to be a change of $0 per 1 day, because even if I divide this by 6, 0 divided by anything is 0, making it $0 per day as far as the rate of change. Now mind you, that doesn't mean you don't pay anything for a late fee, it just means that the rate of change does not change. Now for letter F, for a house not built on time, the price paid is reduced by $50 after 2 days and $75 after 3 days. So I see here we got money, and we have days. And the nice part again is days is a form of time. So therefore that makes the days our independent and our money our dependent. So when we look at our change in y over our change in x, our change in y is $25, and that does go up. And the change in days is 1. And so this is, because they both increase, this is going to be a positive relationship, even though it may not be positive to have to reduce the price you can charge. It's nice if you're on the paying end. And therefore, this becomes $25 for each day that they go over. What you need to do now is go ahead and try out these you-try problems. Bring your questions to class and make sure that if you can write your summary now, that you get that done already.